Here we're going to take a look at finding the domain of an algebraic function. In part A, we look to see if there's anything that might cause restrictions for us in this problem. And we see that because of the variables in the denominator, there might be things that x can't be. We can't let x be anything that would make the denominator equal to 0. So we take the denominator and we say, well, what would make it equal to 0? So we set it equal to 0 and we solve for x and find out when x is -4, that value could be a problem. So we take any values that we got, any critical points where the bottom would be 0, and we plot it on a number line. Then we go back and say, can we actually take this number and plug it in? Would that be okay? And if I actually plug that number back in, I'm going to get a 0 in the bottom, which is not allowed. So I use an open circle to represent that x cannot be -4. Then I pick a test point in either region on either side, so something that I know is bigger than -4, like 0. Am I allowed to plug in 0? Sure, because then I'm going to get a 4 in the bottom, and I am allowed to divide by a +4. Then I pick something less than -4, like -10. And if I put a -10 in the bottom, I'm going to get a -6, and I am allowed to divide by -6. So these two regions that I've checked off are all values that are in the domain. And if I have two checks, that means I'm going to have two intervals. Starting from left to right, it's going to be -infinity to -4, but parenthesis, because I'm not including the -4, in union with -4 to +infinity, again using a parenthesis because we didn't want to include that point. In the next problem, part B, we look at this and we say, are there any restrictions on what we can plug in for x? And I see no fractions, I see no square roots, so I have no restrictions. And the domain is simply, I can plug in anything I want for x, from -infinity to +infinity. In this next problem, I say, is there anything that might cause restrictions? And square roots definitely have restrictions. I don't want to be taking the square root of anything that's negative. So where does it change from being okay to plug in for x and not okay? We can find that out by taking what's inside and setting it equal to 0 and solving for x. So I add 25 to both sides, and I take the square root. But since I introduced the square root, it's really important to remember to do plus or minus. So these are two critical values, one at -5 and one at +5, both that I need to take a closer look at. I start by looking at the values of -5 and 5 themselves and ask, am I allowed to plug them back in without a problem? If I plug in a 5, I get square root of 0, and I am allowed to take the square root of 0, so I do include that point. And same thing if I plug in a -5, again, you get the square root of 0, and we are allowed to do that. So we do want those as part of the domain. Then I pick a test point from each region, something bigger than 5, like 10. I'd get 100 minus 25, which is a positive number, and I am allowed to take the square root of a positive number. When I plug something in between -5 and 5, like 0, I'm going to end up with square root of -25, which I'm not allowed to do. And then if I plug something in less than -5, like -10, once again I'm going to get 100 minus 25, which is a positive number, and I am allowed to take the square root of positives. So I get, again, two different intervals that work. Two check marks, two intervals. The first one goes from -infinity to -5, including -5, so I use the bracket, in union with +5 to infinity, and once again, the +5 is included. In this last problem, I again ask myself, will this problem have any restrictions for what I can plug in for x? And here I see variables in the denominator and inside a square root. So I got a question, what would make that equal to 0? And take a closer look at it. So just like before, I set what's inside the square root, and in this case, and in the denominator, equal to 0, and I solve for x. And once again, I'm sure to remember to do plus or minus when taking the square root, since I introduced it into the problem. Again, I make a number line, plotting those critical values, and then I take a closer look at the values themselves. Am I allowed to plug in a 4 for this? Well, if I do, I'm going to get 16 minus 16, which is 0. And a moment ago I said I am allowed to take the square root of 0 because I'd get 0. But this time the 0 is in the bottom, and that prevents me from plugging in the 4. So this is excluded from the domain. And it's going to be the same exact thing if I plug in the negative 4. Once again, I get the square root of 0, which is fine, but not when it's in the bottom of a fraction. Then I pick test points, again, maybe like 10. I'm going to get 100 minus 16. I can take the square root of a positive number and divide by it. Something between negative 4 and 4, like 0, then I'm trying to take the square root of negative 16, which is not allowed. And then something less than negative 4, like negative 10, which again is going to give me that 100 minus 16, which is a positive number, and I am allowed to take the square root of a positive and divide by that. So again, I find myself with 2 regions, 2 check marks, 2 intervals. Negative infinity up to not including negative 4, and 4 to infinity, once again, not including positive 4.